Okay, I'm going to work a couple of these piecewise. Okay, all piecewise means is that you're going to basically split your graph into 1, 2, 3 different sections, and certain equations get to exist or live on that side. Meaning here, if x is less than or equal to 2, so I'm going to draw my boundary line where x is 2. That's my boundary line. Somebody gets to live over here. There's a graph on this side that's going to go up to that boundary line, and then there's going to be a graph on this side. Okay, so we have two sides here. I'm going to put pink on the top, and I'll do blue on the bottom. Now I'm going to put a table of values, and I know I'm putting y. Well, y is interchangeable with f of x. They mean the same thing. It just means that it's another way, fancy-dancy way of writing y. So y equals either that or y equals this, depending on what you have for your domain. Okay, I'm going to do the bottom one in yellow. Okay, now, what's a number that is less than or equal to 2? I'm going to go with a 1. And I do this. I'm going to say, look, I'm going to put some values into the top equation. I actually write top and bottom. I'm going to put some values in down here in the bottom equation. Okay, in the top equation, I'm going to stick a 1 because 1 is less than or equal to 2. It actually falls inside this domain. Technically, this is the domain. Okay, and it's referring to this side over here. In fact, if I were to, I'll highlight this side. It's referring, the orange part is referring to this side of the graph. The yellow, the bottom equation, is referring to the top side of or the right side of the graph. Okay? All righty. I stick a 1 in, -2. I'll write it all out. -2 times 1 minus 4 is -2 minus 4. I'll get out a -6. So I get 1 -6. 1 -6. Got it. Now I'm also going to stick in the actual boundary line. I want to know, and actually I get to include it on the top one. It makes this a true statement. 2 is less than or equal to 2. So I'm going to stick it in the top one. And I get -4 minus 4. It looks like I get -8. So I put in a 2. I got out a -8. Solid circle. Okay, now some of you might realize this is a slope of -2. Look, down 2 to the right 1. I can also do the opposite. Up 2 to the left 1. Up 2 to the left 1. Up 2 to the left 1. It actually, once you know a point on the graph, you use the slope and you can find all the other points. Okay, so there's that line. It continues on and on forever to infinity and beyond. Second equation. I'm also going to stick a 2 in the bottom equation, even though it doesn't really fall in this domain. Okay, it's going to be the open circle. It gets to touch the boundary line, but with an open circle. The top one got the solid circle because of this underline. That's why this is a solid circle. Bottom one, I'll stick a 2 in. 4 times 2 minus 9. I get 8 minus 9, which is -1. So I input a 2. I got out a -1. I put an open circle. Now I'm also going to put a number that's greater than 2. How about 3? 4 times 3 minus 9. 12 minus 9 is 3. So I've input a 3. I got out a 3. Okay, the slope on this one is 4. 1, 2, 3, 4, 1. 1, 2, 3. Well, I can't do another one. I'd have to draw another line, but you can see it. Take my handy-dandy math tool, and I connect. Notice that on the boundary line, I don't get to include 2 on this blue graph. That's why it's an open circle. Anytime you have a boundary line, you might have more than one point, but I guarantee you only one of them is filled in. Otherwise, it wouldn't be a function. Like if I say who is 2's partner, 2 goes with what? You're going to go down and find the solid point. Say, oh, 2 goes with -8. You're not going to say 2 goes with -1 because it doesn't. That's an open circle. It means just to the right of it, 1.1. Okay, but it doesn't go with that one. Okay, I also want to work the bottom one. The bottom one shows 3 parts of the graph. So I'm going to need 3 colors. Oh, I love colors. Top one, I will do in orange. And it says less than or equal to -2. So I know there's a boundary line here. The next one says -2 to 4. So I know there's going to be a boundary line over here at 4. Okay, I actually am going to have 3 sections here. The bottom line only gets to exist over in the green area. The middle line is going to be the yellow, and it only gets to exist in here And I would draw, I mean, technically there is also a boundary yellow, if you will. Gets to exist in the middle. And then on the very far left, it's going to be orange. So orange gets to exist over here. Okay, now I is ready. I'm going to make a table of values. X, Y. I'm going to do the top, the middle, and then the bottom. Now here's something that's interesting. Whenever I have this many, I have two boundaries. -2 needs to go into the top one and the middle one. Because I need to know, obviously, the bottom one is going to be the open circle. And then it's going to go over, I don't know what it's going to do, but I promise you when we get to the 4, it gets to be a solid circle. This one's going to be a line doing something like this, and it's going to come up to a solid circle. And this one's going to start with an open circle and do something like that. Just because I can look at the slope and tell what's going to happen. Actually, this line would go uphill. Anyway, a number that is less than or equal to -2, I'm going to put in a -3. -3 minus 1 is -4. So I input a -3 and I got out a -4. Okay, now I'm going to stick in a -2. -2 minus 1, I get out a -3. -2, -3, it's a solid circle because that's underlined. So this one gets to actually grab hold of that boundary line. 1, 2, buckle my shoe. 3, 4, shut the door. There we go. Okay, now I need to do in between. Okay, in between, the reason I'm putting -2 is I need to know where the open circle goes. I know it's an open circle because there's no underline here. It doesn't say less than or equal to, it just says less than. So I'm going to stick in a -2. 2 times -2 minus 1. I get -4 minus 1, I get out a -5. So -2, -5, open circle. Okay, I can't have two closed circles. That's an open circle. Now I need a number. Actually, I'm going to stick in the 4, the other boundary. I need to know what happens on this boundary line. And I know it gets to be solid on this one because of the underline. So I've got 2 times 4 minus 1, which will be 8 minus 1, which is 7. So 4, 7. It gets to be solid because of the underline on that 4. So I'm going to connect those two with my handy dandy math tool. And last but not least, let's pick another color. I think I have a green. Come here, baby. I got green. Okay, I'm going to stick a 4 in the bottom one, even though it really doesn't belong in this domain. I just want to know where my open circle goes on this boundary line. So I'll stick a 4 in, -3 times 4 plus 8. So I get -12 plus 8. I get out a -4. So 4, -4, open circle. Okay, you can't have two closed circles on one vertical line. It wouldn't be a function. Now another number greater than 4, how about 5? -3 times 5 plus 8 is going to be -15 plus 8 is going to be -7. So I input a 5 and I got out a -7 right here. Do. Technically, there would be arrow on this one and arrow on this one. Not on this one. This one actually starts and stops.